Algebra 1, Investigation 12. We are just looking briefly at matrices and getting used to this idea of showing tables in a mathematical way called matrices. So I'll just start reading here. The table shows the price of tickets sold at a local movie theater. We can see all of the different types, child, student, adult, and then the prices for a matinee and regular. Use a matrix to organize data, such as a price of movie tickets. A matrix is a rectangular array of numbers in horizontal rows and vertical columns. Each number in a matrix is called an element. An element is any individual object or member belonging to a set. So below is the matrix for these ticket prices. Notice that these entries in the table above correspond to the elements in the matrix. So you can see how each of these numbers is really in the same spot from the table to the matrix. You can see for the child we have 5 and 7 up here. Well, then our first row is 5 and 7. 6 and 8 refers to the student, 9 and 11 refers to the adult. And we can see all of these in their correct columns as well, showing that this first column is for the matinee prices and the second column is for the regular prices. So let's look at a different situation here. The table below shows the number of items sold during the first day of a school fundraiser. Use the data in the table to create a matrix that represents this situation. Well, just like above, we are going to take this table and make a matrix that looks very, very similar. So it has the same columns, same rows, all in the same order. For example, t-shirts, I had 10 medium, 7 large, so that would be my first row. Hats, I had 3 medium and 2 large. Sweatshirts, I had 4 medium and 9 large. So that would be my matrix. Number 2, explain how to use the matrix to calculate the total number of sweatshirts sold during the first day of the fundraiser. How many sweatshirts were sold? Well, our sweatshirts here refer to the third row, and so it doesn't matter if they're medium or large, we just add together 4 and 9 to get 13 total sweatshirts that first day. The dimensions of our matrix with m rows and n columns are m times x. Each element has a specific position in the matrix that is relative to its row and column. Complete the statements. Refer to the matrix and the number of items sold during the first day. So number 3, the matrix has how many rows and how many columns? Well, we have 3 rows. Those are my horizontal, so 3 rows, and vertically 2 columns. So the dimensions of the matrix, well, I do rows and then columns, so it's a 3 by 2 matrix. And then it asks for the element in the third row, so 1, 2, 3, so I'm in this row. And second column, okay, so 1, 2, I'm in the second column, is 9. So that refers to those 9 sweatshirts that were large that were bought the first day. Number 6, describe the dimensions of a matrix representing data about a school fundraiser with 5 types of items available in 4 sizes. Well, my types of items are shown in my rows. So if I have 1, 2, 3, 4, 5 different items, and then the columns show the different sizes. So if I have 4 different sizes, then I could have all of these 5 items 4 times, so 4 columns. So how would we describe the dimensions? We have 5 rows and 4 columns, so it's a 5 by 4 matrix. All right, since matrices are a method of organizing information, sometimes they are added or subtracted to get new information. Matrices that have the same dimensions can be added or subtracted. They have to have the same dimensions in order to be added or subtracted. So the table shows the number of items sold during the second day. Let me just rewrite down here the first day because it sounds like we're about to use it. So we have 10, 7, 3, 2, 4, 9. 10, 7, 3, 2, 4, and 9. Okay, so explain how to find the total number of large hats sold during the first 2 days of the fundraiser. Well, let me turn this table into a matrix, and we would have 8, 3, 1, 5, 4, 7. And since I want the number of large hats, that means that I'm looking at the second column, second row, second column of each of these, second row, second column. So I'd be adding together 2 and 5 to see that there were 7 large hats that were bought in the first 2 days. All right, and then after that, we want to explain how to use matrices to find the total number of large hats sold during the first 2. Oh, sorry, I think I already did that. All right, so see, number 7, explain how to find the total number of large hats sold. Explain how to use matrices to find the total of large hats. So we showed that with both matrices, and you could go in your table and find the large hats in both of them. So number 9 and 10 refer to what you can do with a calculator with matrices. Go back and look at that lab for matrices if you haven't already, to refresh yourself on how to do this or learn how to do it for the first time. I'm just going to show by hand what we would do so that you can use that tool as well, along with what you would do on your calculator. So use matrices to model the sum of the items sold during the first 2 days. Then add using graphing calculator. Well, we can go ahead and do this by hand a little bit by just copying down our matrices, so 10 and 7, 3 and 2, 4 and 9. And we're going to add to that 8 and 3, 1 and 5, 4 and 7. Remember, each of these refer to similar things. So 10 refers to the medium t-shirts in both days, or 10 in the first day, 8 in the second day. So if I'm going to add these matrices, I have to add together the ones that are in corresponding spots. So in this case, 18. 7 corresponds to 3, so we would get 10. 3 corresponds with 1, so we get 4. 2 and 5, 4 and 4, 9 and 7. Okay, so we would say the total number for all of these items being sold in a matrix is shown right here. All of those added together. We have to, though, use the corresponding spaces in order to add the matrices. Now number 10 wants us to do the difference between the matrices. So let's write them down again. 10 and 7, 3 and 2, 4 and 9. We're going to subtract from that 8 and 3, 1 and 5, 4 and 7. Now, let's look at each of these. When I do this, I am going to do it just like we would with subtraction, with the left one minus the right one. It's okay if it gives me a negative number. That's just fine. I just want the difference between these two. And I still have to use corresponding spots. So 10 with 8 gives me 2. So 10 minus 8, 7 minus 3, 3 minus 1, 2 minus 5, 4 minus 4, and 9 minus 7. Okay, so we would say the difference between these two matrices is shown in this second matrix here. So we can add and subtract with these matrices if they are the same size, so that we can get totals or differences between different amounts for situations. So matrix addition also has a geometric application. So complete the following table by finding the coordinates of our vertices for triangle ABC. Okay, so point A has x coordinate of -1 and it looks like y coordinate of 2 right here. Our B coordinate is completely filled in at -2, 1, and C is at 2, -2. Okay, and then after that, number 12, use the data in the table to create matrix A. So matrix A, I'm just going to show here as -1, -2, 2, and then 2, -1, -2. So in this case, we have a 2 by 3 matrix, 2 rows, 3 columns. Use a graphing calculator to find the sum of A plus B if B is right there shown. Well, I'm going to rewrite them down here just to give myself some space. So -1, -2, 2, 2, -1, -2. Very important to keep all of these in the correct order, otherwise it doesn't work correctly. So we're finding the sum with B, so 3, 3, 3, 2, 2, 2. What does this mean, what we are doing? Well, this means that in all of the x coordinates, I'm adding 3, and all of the y coordinates, I'm adding 2. That's what it looks like to me. So let's do that. And we say we have this -1 and 3 in the same spot, so we add those together and get 2. -2 plus 3 is a 1. 2 and 3 is 5. 2 plus 2 is 4. -1 plus 2 is 1. And -2 plus 2 is 0. So all of those coordinating spots, we add them together to find the sum here. So we get a 2, 1, and a 5, 4, 1, and 0. Well, use the elements of a plus b as the coordinates, I'm looking at number 14, of triangle a prime, b prime, c prime. Plot them. So let's do that. And remember, this is point A, point B, and point C. So we're using 2, 4 as my first one, right here. 1, 1 as my second. So here's my A prime, B prime, and then C prime is at 5, 0, C prime. Okay, so describe the relationship between ABC and A prime, B prime, C prime. Well, like I said before, this is a translation of over 3 on the x and up 2 on the y. So you can see that, let's say with C, over 3, 1, 2, 3, and up 2, 1, 2, because we've added 3 to each of the x coordinates and added 2 to the y coordinates. So this is a translation. What matrix would translate ABC 1 unit to the left and 3 units down? Well, just like we would do here, I would say I'm going to do one thing to the x's and something different to the y's here. So to the x values, that's 1 unit to the left. Well, going left is -1. So I would do -1, -1, -1. And then for the 3 units down, that's on my y coordinate, so I would be doing -3, -3, -3. All right, so that would be my matrix to show that. And what matrix would be used to translate triangle ABC to triangle A prime, B prime, C prime using matrix addition? Well, let's see what this transformation is. Let's count from A to A prime. So let's go to the right, 1, 2, 3, 4, 5. So I know that for my x coordinates, I did 5 on each of those, and I have 3 coordinates, so 5, 5, and 5. And then from here I went up 2 on the y's, so 2, 2, and 2. All right, so for each of those, I did one transformation for each, and I made my translation. So we can also transform a geometric figure through scalar multiplication. This is a dilation. Scalar multiplication multiplies a matrix A by a scalar C to find the resulting matrix C times A. Multiply each element of A by C. So number 18 says, use matrix A from the previous exploration. What would be the effect of multiplying each element in matrix A by 2? So we go back and rewrite our matrix, and we would say my original matrix is right here, -1 and 2, -2 and -1, 2 and -2. So if this is my matrix A, if I want to multiply each of these elements by 2, I'm basically going to take each one of them and literally multiply by 2. So you can do this by hand or practice with that graphing calculator for number 19. So I would get -2 and 4, -4, -2, 4, and -4. All of those get multiplied by 2. So use the elements of 2A as the coordinates for the vertices of A double prime, B double prime, and C double prime. Plot the vertices to create the graph of the triangle. I'll let you do that and see that it truly is a dilation, in this case an enlargement, because we're getting 2 times bigger on all of those coordinates. Okay, and that is 21 as well. We have a dilation, it's getting bigger. And to finish up this investigation, just 22 and 23 is left. What matrix would create a triangle 1/4 the size of triangle ABC? So in this one, what we're trying to say is if I want a triangle 1/4 the size of ABC, you can see how in this one, actually, sorry, we're not referring to this one right here for number 22. We are just saying in general, how would we do this? Well, this is scalar multiplication. So I would say in this case, and let me just check myself here to make sure that this is what they're looking for. But for this, I would say just 1/4 times the matrix for ABC. All right, let me just check. All right. So, in this case, yes, in general, if I want a triangle that is 1/4 the size of triangle ABC, I would be using 1/4 of each of those coordinates. Now, you can interpret this another way. If it's wanting 1/4 of the area, then I would only need 1/2 of those side lengths. So it depends on how you interpret this. If you want 1/4 of the dimensions, then I would be doing 1/4 of A. Okay, that's if this is a perimeter scale factor. If this is considered an area scale factor and I want 1/4 of the area, then I would only need 1/2 of those side lengths because we would square it in order to get that. Okay? A little bit of a weird question there, but that's okay. All right. Lastly, number 23, describe the relationship between triangle ABC and A prime, B prime, C prime. Well, we can see if I have AB right here has a side length of 2 compared to a side length of 6. And we can see that in all of it, which means we must have used a scalar multiplication of times 3. So this is a dilation, an enlargement of this triangle. All right, so that is all we have as far as scalar multiplication, adding matrices, and using matrices to show different tables. I hope this video helps with your homework and for studying.